So here's the situation. We need to do lesson 11 today, and it should take, I mean, we definitely should get it done in the full block, but there's a lot of stuff here. So, but we'll keep it moving. Okay, so last time I wasn't here, but I'm sure you all did lesson 10, the first look at traversals, which we've been talking about for a little bit. It is a combination of a list and a loop, okay? Which, if you have a list, you almost always will be looping through it. That's just a thing of programming. Um, you just aren't going to just have a list that sits there and you type things into it and it's almost useless. A list is almost useless without being able to loop through it. Unless it's short and you can memorize everything that's in it, which is not going to be the case for almost anything that you program, especially because of the fact that lists change length as a program runs. All right, so I don't know why I left all these running. That's certainly going to hurt things. Let's go back and, all right. Nope, 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 nope. And good. Okay, bubble one. So we get a list of fruits. And okay, so most recent 3 assignments have been graded, and we are getting significant lag in the Wi-Fi, so that's not ideal. Hopefully we don't have to stop. Okay, so the most recent 3 assignments have been graded, and they should be in your grade book. And same situation with regrading policy. Okay, the assignment should be on the form now. If you do them late, you could do that. The other thing, the most common mistakes that I saw were, even though I tried to make a point of it, instead of doing in a place where you need a lowercase I, people still were putting a 1, like a numeral 1, which it wasn't in an index place like this. It would be like in a where we did the loop for all the different icons, and the point was to loop through and set the property. That's lovely. Okay. So all right. I would prefer those of you who are in class to do the work that we're doing in class. That would be great. So I could see how that would be an easy mistake because of the particular typeface or font, technically typeface, that we're using, but you need to know when to use which. The other problem that I can see evolving is not knowing when to do length versus length minus 1. You just ask yourself, do you want it to happen to every item in a list? Then it's dot length. If you're interested in the last address, it's length minus 1. That's a key fact moving forward. All right, so we get to lesson 11, bubble 1, and we're given a list of strings, which happen to be letters in the order that spell fruit, but that's irrelevant for our sake, and a list of numbers that are supposed to be the prices in dollars that correspond to those fruit. This is a good example of naming lists in a useful way by making the full list plural. Same thing with prices. Makes it easy to tell that a variable name is actually a list of or the name of a list. And so what's happening, they are declaring a couple of other variables, and which aren't the way that it's a variable that is only used once right there, and it's only this. So you could technically just do this. This would be the same thing. But what's happening is we're doing a loop through the entire list. And because the prices list and fruits lists are the same length, it doesn't actually matter the name of the list you use because dot length is just the number. And for each item, they are console logging whatever is in fruits at index I, concatenated with the word cost, concatenated with whatever's in price at index I, where I is our counting variable. We've seen this before. Every time through the loop, I changes. I goes up by 1. And that's not just the way we're counting the number of times to do the loop. It's how we are accessing each item in the list, because we are using that counting variable as our way of accessing each index in the list. We hit run, and it's going to print out every item in the fruits list, followed by the word cost, followed by the item in the price list at the same index. That's key as we move forward, especially when we get into data tabs, is the fact that lists are, I don't know if the technical term is parallel, but I think that's a good way to describe them. Okay, so we need to do the same thing here, where we just need to, it's the exact same setup, have this printout to the console log using the provided list of names and grades, which should look a lot like this. Okay, I'll give you a minute to solve for that one, which is create and assign lists. Go. All right, so same situation. We have our two lists. We want to loop through the lists. So not only does the example not need those variables there, it doesn't need these. It could just make them local, but let's just copy for the sake of consistency. So we are just declaring a couple of variables similar to the other one, where we have our list of students will be not really filtered, but accessed and put into a temporary variable called student. And the other one is grade, being singular. Then we want to do a loop. How many times do we want to do a loop? We want to do a loop students.length, number of times. Could also be grades.length. It's not a big difference. Then each time through the loop, we are going to reassign student and grade to whatever's in the list, in their respective lists, at that position. So student, every time through the list, will be reassigned whatever's in students at index I. Oh, no, I did grades. I tried to get too clever with my copy paste. And there we go. Students at index I, which again, you're going to need to type it in. Wait, do we have I guess you could use the list index block if you wanted to. But if you're typing it in, it's the name of the list, which in this case is students, and then open square bracket, the index you're trying to access, which in this case is going to be whatever the value of I is each time, close square bracket. And then grade's going to be the same thing. Grade is going to get whatever's in grades at index I. And then we can do a console log that will be our concatenating, which will be student, not in quotes, because it's the variable, followed by the string is in grade space close quotes. Is that the verbiage they want? Yep, is in grade. And then concated with whatever gets placed in grade each time through the loop. And because this console log is in the loop, inside of the loop, it will do it each time, where if we had it, well, I'll show you in a second. So it has each of them, because each time it writes it through the loop, but I just need more pixels. Okay, so every time through the loop, it's grabbing whatever's in those positions and then printing them out to the console. If we had the console log outside of the loop, it would go through the loop and keep adding each thing or replacing it, but it wouldn't get, the only thing that's going to print out probably is the last one, because we're not console logging it until it's done looping, at which point these variables will only be whatever's in the last position. But that's not what we wanted. We want it to print out everything, so it should look like that. Okay, let's go on to bubble 2. Okay, bubble 2. We have a similar situation. We've got a list of strings, which happen to be the names of animals. And we have well, this is what they've given us. The printout, when we get here, is this string. Where are we? Here's my list of favorite pets. Then we loop through the entire list. And the whole point is we're trying to construct this concatenating of a numbered list. Well, each line is going to be a number followed by a colon, followed by whatever is in the list at index I. We've seen this trick before where I think it was like a to-do or reminder app where normal people start lists with 1. Computer scientists start lists with 0, or start counting from 0, that is. And so in order to have a list for a user to see where the first item is 1, when you are actually printing it or displaying it or setting properties, you need to increase I, so that if you're using it like we are here in this concatenating, it will let whatever the first time through I is 0. So if we didn't have this 1 here, otherwise known as +0, it would have the index of each item, but that would start us from 0, which is not what we want. Okay, and there isn't anything you need to do to that one other than learn from it. And we need the same thing here, except I mean, the exact same thing. Our goal to print out is a list. I mean, it's almost exactly the same thing. A list starting from 1. And this should take you even a shorter amount of time. All right, well, we could just copy and paste since it's almost identical, but let's do it from scratch, or I'll do it from scratch so that you can see how we are building it. Okay, so we have our setup here. And in fact, I'm going to get rid of the console log from the previous one just so it doesn't show up in our printout. And we want a loop. Okay, and they have a the way they're building it. In fact, I'm just going to do this as short as possible because I think it's more realistic. Okay, we want, excuse me, we want to do a loop. How many times do we want to do loop? We want to do a loop dot length number of times. And a quick another tip, you almost never will have a dot length -1 in the number in this part of a for loop. Okay, the only time you would have a -1 is if you were checking each item in a list against the next item, in which case you would want the loop to stop one short of the end so that you could check the next one. But this isn't saying stop at the last one. This is saying stop at the one before it. Other words, never mind. I probably shouldn't be throwing in edge cases while we're on day 1 of this stuff, or 2, or whatever it is. Okay, so we have a loop we're going to do to each time through, and I'm just going to do this in a single console log statement. What do we want? We want a list, a numbered list, which is going to look a lot like the previous one, with starting with the getting the list to start from 1, which we can't just do I plus 1 plus the colon space plus favorite colors index I. Okay, so this is sort of the way you'd think of it, where I plus 1 allows our list to start at 1, then, or yeah, to start at 1, and then the colon in space, and then whatever's there. But this first thing, we are doing actual arithmetic. Okay, I is going to be a number starting at 0 and going to however many there are, and we want it to increment. This plus sign means math. This plus sign means add. This plus sign means connect. Okay, anytime you're in a string of, or you're concatenating, and you need to do math, you need to wrap the math in parentheses. I suppose the technical term would be arithmetic. Okay, so we have our list ability to start at 1 instead of 0. We have our little spacer, so it looks right. And then we have the list that we're looking at. And every time through the loop, we are getting whatever's in the list at the index, whatever I is, every time through the loop. And I think this will work. Yeah. Okay. I didn't get rid of the pets thing, but there you go. That's what that looks like. And I'll switch it to text mode because people are having trouble with, like I said before, having trouble with typeface. There we go. I'll space it out too. So there's a plus, and I don't need to space it out. All right, so let's go on to number 3. Number 3. All right, so again, we have a list of fruits. Is this one even different than the other ones? This is simpler than the other ones, right? Am I forgetting something? This feels out of order. But okay, well, we'll just fly through it. It's the same thing as what's up there. We need a loop. And we are going to console log everything in the list called vegetables. So the number of times we want to loop is vegetables.length. And every time through the loop, let's just go straight to console log. And let me, I can tell that I would like to move things farther up on the screen. Okay, and so we're going to loop, and every time through the loop, we want to console log whatever's in vegetables at index I. Okay, and we don't have any concatenating of strings to make it a sentence, but yeah, there you go. And let's get rid of that. That's easier. Let's go on to level 4. All right, so we have a list of animals, and what we're going to do here is our first filtering. Okay, filtering is exactly what it sounds like. We go through a list and we keep the things we want, just like any sort of filter, or get rid of the things we don't want. But in this case, we are keeping the things we want. And the things we want are animals with more than 5 letters in their name. How are we going to get that? Well, what's interesting about strings is strings have a dot length property as well. Okay, and let's do, actually, let's, I'm just going to comment out everything for the sake of learning. All right, so here's our list. You don't have to copy this, just as long as you're listening and learning, that's fine. Let's console log the full list. Okay, the full list is called animals, and if we console log that, we'll get our full list. Okay, now if we just want the first item, we're going to do console log animals at index 0. If we console log animals at index 0, we will get the word alligator because it's the first thing. What's interesting about strings is strings have a dot length property as well. If we have a string like var my string is that, and if I console log my string dot length, it's going to print out 4. Okay, so this string has a dot length property. Now, if I want to find the length of an item in the list, how do I access that item in the list? That item is animals at index 0. Animals at index 0 dot length will tell us how many letters are in this first string. Hopefully, yep, there you go, 9. Okay, so this is how we access any element in a list, the name of the list and its index, and dot length will tell you how long is in a string, and since this is a list of strings, we will be able to utilize that. Now let's do the actual thing that you are going to follow along. We have a setup. They've given us the list of animals. They've given us a loop. They, like I said, the sort of unnecessary animals is animals at index I, and then we're just using it. If the thing we're looking at, dot length, is greater than 5, it gets appended to the filtered list. Okay, having a filtered list is the way we're going to keep track of things. Instead of removing items from the main list and being left over with just the things we want, we're going to grab the things that we want and append them to what starts out as an empty list, and we'll gather all the things that match our conditional. In this case, our conditional is that the string has more than 5 characters in it. And so in our list, or when we run it the first time, the only strings that have more than 5 characters from the list of animals are these 3. Okay, so you're going to do the same for the list of students. A huge hint, it looks a lot like the list of animals, and except it's 6 or more. Okay, go. What's up? All of them. They're short ones. They're not full period ones. Are you that far ahead? Just out of curiosity, just a heads up, just to give us an idea of where we're going. That's fine. I don't mind that at all. Is Sean here? Sean in front. How are we going to do this? So we want to loop. Let me we want to loop, and how many times do we want to loop? We want to loop once for every item in the list, called students, I think. Yeah, so we have a list of students. We are getting an empty list waiting to receive the things that match our conditional. And so we want to loop through students. So students.length number of times. And every time through the loop, we are going to check, is the item we're looking at, if students index I, which is the item we're checking every time through, dot length is greater than or equal to 6, with filter students to have those with 6 or more letters, greater than or equal to 6, which length of strings is always going to be an integer. You could just do greater than 5, but greater than or equal to 6. If the thing we're looking at has more than 6 characters, we want to append it. Okay, append means add to the end of a list, and the order isn't super critical, so just throwing it at the end of the list is fine. The list we want to append to is called students filtered, and the thing we want to append is whatever we're checking. Sometimes we'll be checking something from one list, and we want to append something from a different list at that index, but here we're just keeping whatever we find to be true. And then at the end, it's going to print it out with the thing we have. Okay, students with 6 or more letters is this list right here. All right. Okay. I can come back to these later on, but let's keep moving. I don't know how long the rest is going to take. Shouldn't be too bad. Okay, bubble 5. We have a program that traverses a list of prices trying to find the minimum. Okay, we have talked about this like very briefly, but the idea, okay, so the second one isn't done yet. We need to do it. The way this works is we are going to start, well, we need a variable that's going to hold our minimum price. Okay, this is the one that's already done for us, the find minimum value. Given a list of numbers, we are going to go through each one and find the lowest one. The way we're going to do that is we need a variable that's going to keep track of the sort of reigning champion for lowest and compare whatever the lowest one is, or whatever the lowest one is, to each item. And if we find one that's lower than the current lowest, that variable is going to get assigned that number. So each time we check to see if the thing we're checking is lower. If it's not, we go on because the conditional will be false. And but if it is lower, our reigning champion variable will get assigned that new number. So moving forward, that will be the one that it checks. The problem is that normally when we declare a variable that is going to be a number, we frequently will start it at 0. Like if you want to count the number of times that something happens, of course. The problem is if we start minimum price at 0 and then compare it to this, it will be lower. Then compare it to this, it will be lower. And our starting minimum price of 0 will win lowest price. The problem is 0 isn't on the list. So you can't have the minimum number, the lowest number in a list of numbers, be a number that isn't on the list. So we can't start our sort of reigning champion variable at 0. What can we start it at? Well, let's start it at the first item in the list, because the first item in the list has the potential for being the lowest. It might not be, but it doesn't matter. We will at least start our reigning champion variable with something that could be the finish thing, which let's just start with the first item in the list. Okay, so long as the list isn't empty, there will be something at index 0. And that is what that's what's being used to hold that. And again, they're doing the thing that you don't need to do with creating this variable, getting the thing right there, and then just using it where you really would just, I think this simplification that they're doing in this case is not beneficial compared to other times where they sort of spread out the creating a variable. And the reason for that is prices. I mean, it does save a little bit. You don't need to change the things I just changed. That part works, but I want to explain it this way. And that is, we're going through an entire list of prices. If the thing we check is lower than our reigning champion, the container that's holding the number that is our reigning champion gets whatever we're checking. And that's how you go through the entire list and get whatever the actual lowest one is. You need to do the same, essentially, just right there. Pretty much just copying what's the other example is, where we're checking for the maximum, the highest number in a list. All right, so we have the loop that checks everything in that same list, and we are just going to do our conditional. Okay, and we are checking if the thing in prices at index I, the number we're checking, is greater than max price, which is the variable that's holding the reigning champion as we go through the list. For maximum, if the thing we're checking is greater than our current greatest, we want the variable holding the current greatest to get the one we're checking. Prices at index I. We are replacing the previous champion with our new champion. And when we get through the entire list, we'll have the highest number, and it should be whatever. We can do a quick eye test and see that 325 is the highest number. This format, or this, I don't know, whatever they call it, programming paradigm of checking and keeping a sort of either running total or running champion for something is pretty common. All right, let's go on to 6. Is 6 the one that has extra? No. All right, here we get to start to experience the majesty that is traversing list. And that is because we get to start using the data tables, which you can imagine on a long list, it is far, far more reasonable to do a loop rather than just our previous list of prices that had 6 numbers in it. You could just look. Okay, our goal for this one, and they've already imported the list for states, names, and year list, which if you go to the data table, you can see that they've already imported it into the project, and which it needs to do in order to get to it. And the table is everything about US states with a column for, okay, all these things. Why can't I move over? Oh, that's weird that the scroll bar is there. Yeah. So the only ones we are worried about for this one are the ones they've brought in, which are the name of the state, which makes it useful, and the admission year. And they are being brought in and assigned to the list, state list and year list. Okay. And we could console log them and they would print out the full list, but take my word for it. We are getting an empty list that is the filtered list, but instead of just calling it filtered years or filtered admin years, it's called since 1900 list, which makes sense. And they're doing the thing again with the sort of spread out year and state, where they're just making the single time variable that really would look more like if year at index I is greater than 1900, we append to the list since 1900 list whatever is in states at that index. This is the way you'd probably see it. It's exactly the same as it was a second ago. As far as output, you don't need to change it. You just need to understand the difference. Okay, so here is the setup. We are checking the entire list of years. We are going through the entire list of admission years. And if this number is greater than 1900, meaning since 1900, we are going to get the name of the state at the same index in the states list. Okay, because whatever's in admission year at index 1, which this is the second I'm going to list, it's index 1. Whatever's in admission year at index 1 is the admission year for whatever state is at index 1. So as long as we're doing everything inside the same for loop, we can use I to access the same position in any one of the lists. And the same position in any one of the lists is essentially the row. And it's all related to the same state. Okay, so we get here and they're doing the, where is state actually used? Oh, it's probably used again down here. Okay, so we have the since 1900s list, works fine. We want small populations of less than 1 million using the populations list, which also has been brought in. Okay, so you are copying, I mean, it's very similar to what's here for the admission year list, but just changing what's in the, or searching for populations under 1 million and appending them to the small population list. And I'll give you another few seconds. Okay, the same basic setup. We're going through states list. Well, again, it doesn't matter the name of the list we're looping here, since all the lists are going to be the same length. It's just how many times to loop. And I'm going to do it. Well, I don't want to switch it yet. We need a conditional. We are checking if whatever, in order just to slide things over, I'm going to put, just bring the less than. Okay, whatever's in population list at index I, if it's less than 1 million, which 6 zeros, it's hard to read, just typographically. But if whatever's in population list at the index we're checking is less than 1 million, we want to get the name at that same list and append it to our filtered list. So the filtered list is what's going to get whatever's in state list at index I. Okay, we're checking, well, we're doing a loop once to every row, doesn't matter. And if whatever is in our list of populations at the index we're checking is less than 1 million, we are going to get that state's name, or get whatever state is in the state's name list at the same index and append it to our small population list. Okay, the key is understanding that I is going to be the same value the entire way each time through the loop. It changes, but while it's in the loop, it's the same number. And we hit run here and it should come out. Here are the states with less than 1 million residents. Okay, bubble 7, we have 3 of these that we're going to do all of them. They're short ones. They're not like the full period ones. So let's go ahead to A, which I think I have already up. Should be this one. Okie dokie. All right, so this app allows users to enter a new grade, and it lets them add it to the list, and it already works. And it already works to the point where it's putting them on the, it's already displaying them in this text area every time the user types a number, which I'm guessing it, yeah, it does let you, we'll fix that. It does let you add a blank, and will it let you add, nope, it won't let you add a string, but that's something we're definitely going to fix. And then we're not going to do a clear, a wipe button, but it would not be difficult to do. And the goal is to have it so that once we have items in the list, the user can click calculate average, and it will find the average of all of these integers using standard arithmetic method that we will just sort of spread out. Okay, so we start out the program code that we get an empty list. Great. Every time the user clicks on the add grade button, the program gets that number and appends it to the list. And then calls update screen, which update screen already sets the output. Okay, it sets the input to an empty string, which is great. That's the sort of pro way that we will always have, and they did it for us, which is great. And it has the set property for this text area to be the sort of trick, the dot join trick, where it takes an entire list of anything and can combine it, or in this case, concat it to each other with a new line command that allows it to sort of go out in a list. And, you know, a left justified list. We need, first thing we're going to do, and this isn't in the instructions, I don't think, but it is required, and you'll lose a point if you don't do it. We're going to check to see if the user actually puts in a number, because it breaks it if the user clicks add grade while it's empty, that gets added to the list. An empty string or a null what does it actually look like? Let's console log grades list. And this is a more common use of console log just to sort of see how the program is interpreting things. Okay, so it's not a number is how it's interpreting. It's not bringing in as an empty string, and that's because we already have get number. All right, so how are we going to check? Well, we are getting new grade, or we are getting that number, assigning it to new grade, which is necessary, where you could do this all in one line, append item to grades list, whatever's there, but we can't do a conditional if it's in the same line. So we're going to check, and this is just a sort of a guard clause where we aren't going to let what's supposed to happen inside this event handler happen if it doesn't meet the requirement. Okay. If new grade is does up can we do does not equal not a number? There's a couple ways to do this. Nope. Does not equal, what about empty string? Is that going to block it? Nope, that doesn't block it. We got to check if it's a number. And how can you check if a number is a number? If it's greater than 0 or if it's less than or equal to 0. Every number is either great, and you could use any number as long as one side has the equal sign. Okay, if the thing we're bringing in is greater than 0 or, I'm not typing there right now, there we go, or double vertical bar, which is shift backslash, new grade is less than or equal to 0. If it's either of those things, it's a number. If it's not a number, that will be false. If it's letters, that will be false, because letters are not greater than 0 or less than or equal to 0. You can actually do greater than inequality operators for strings or for letters where it has them in alphabetical order, where the letter B is greater than the letter A. Sounds weird, but it's how you do alphabetization. Why can't I say that word? How you alphabetize things is with that. But here, comparing it to 0, this should work, hopefully. Let's put in a number. Numbers work, and yep. Okay, so it doesn't break it anymore. That was the requirement for that. Double checking to make sure that the number we're bringing in is a number greater than 0 or less than or equal to 0. If you don't have, you can't say if it's greater than 0 or less than or 0, because then 0 would be false. We want 0 to possibly come in, and that's why the sort of, it's not really the opposite, but the partner of less than is not greater than. The partner of less than is greater than or equal, and vice versa. You need, in order to cover a span, one of them has to have equal. And okay, so we've done enough to start. And so how are we going to do an average? Okay, I'll give you the list, okay, or the to-do list. Create a variable to total up all of the numbers. Divide. No. How would you say that? Average. Find average with using the length of the list. Okay, those are the 2 steps, and the only things you need to do for this. And Then you need to update set property using that average. Okay, so these are the three things you need to do, those three comments, and I should probably take a couple minutes. Go. All right. So, thinking over this, I do think we should probably do set. No, it'll work. Okay, so here's what's up. We need a variable used for totaling things up, and we need to keep track of the average by dividing. And dividing the total by however many items there are. And if we want to use either one of those outside of this event handler, they need to be global variables, which let's just go ahead and put them up at the top in case we want to use them elsewhere. Let's just call it total, which doesn't really need to be very global, but it's fine. And average, average is not really zero. We are going to need to protect these with a guard clause in order to make sure that it doesn't try to do division on an empty list. We'll get to that in a second. Okay, when we click average grade button, we want to total up all of the items. So we are going to do things grades list dot length number of times. And every time through the list, we're going to be looking at grade list index I, and we want to add that to our running total. So running total, which is called total is going to get whatever it already has. Every time through the list, it will have something starting with 0. It's going to get whatever it already has plus the thing we're looking at, which is grades list index I. All right. And when we get to here, our total will have everything, the sum of all of the grades. And we want to find the average, which average is going to be how do you find the average? Well, average is going to be total divided by however many items are on the list, which is grade list.length or grades list.length. That's how many items on the list. The average is the sum of all of them divided by how many there are. I call it AVG. I did. And when this is done, we can go ahead and send it to update screen. So we'll call update screen again. And inside of update screen, let's set the property of our, this thing is called average grade. So we want to set a property here. No, set property. The element we want to set the property of is called average grade. Average grade label. Average grade label. And the property we want to set is its text property. And we want to set it to AVG. Now, this should work so long as we don't let the user break it. And so we have a list of some things, and we hit calculate average, and it will give us the average. The problem is that you can see here, every time we click, we are keeping, okay, so there it's clearly breaking. If you click calculate average a bunch of times, it shouldn't increase. The reason why it's increasing is we aren't wiping total. Every time we click it, total is getting the value of every item in the list every time we click it. So in order for this to work, so that every time we click calculate average, it is a true average, we need to wipe total every time through. So total gets 0, which if we just declared var total inside of the event handler, it would have solved that also. And it would have been fine because total isn't used anywhere outside of this situation. I'm not worried about you having the your average grade thing. You know how to concat things, hopefully. Now, the problem is if the user clicks calculate average when the list is empty. Okay, and does it fix it? It does fix it. But, I mean, it does let you go back. Like if you click out and have not a number and you go add and then average, it will fix it. But that's still pretty amateurish to have it break when the user clicks a visible button. The way we're going to solve that is by protecting everything in here. We don't want the average grade button to work if the list is empty. So we are going to put everything inside of the button in a conditional. We're going to get an if. We want to protect everything. So we'll put everything that was in our event handler inside of this conditional. And what condition are we checking for? We're checking if the list.length is greater than 0. If gradeslist.length is greater than 0, then you can commence with the averaging. If it's not greater than 0, that means the list is empty, and don't try to average an empty list. Okay, and we hit go now, and it doesn't break, so that's an improvement. I'll give you a second to look at this, and I'll switch it back to text mode. That's as big as I can get it for here. What's up? Did you declare it globally at the top? Var average is I made it a global variable. Oh, it does. Average has to be a global variable in this because we're using it 2 places. What do you mean? the major difference between total and average is that average is used in two places. It's used in two different functions. Total is only used inside of this function. It's only used here, which means it definitely could have been a local variable. Do you have gradeslist.length greater than 0? Yeah, for the if the guard clause. Okay, give me a second here. It's probably pretty quick. That. While this is loading, we'll solve this problem and then we'll come back for bugs at the end. Okay, average grade list dot length is greater. Var total is 0. Okay, you do have it local, that's fine. Grades list, total gets total, grades list. Oh, it's not total gets total plus grades list dot length index I. It's just the item we're looking at. On your line 19, you have total gets total plus grades list dot length index I, which isn't a thing. We just want grades list index I on your line 19. Oh. Get rid of dot length on your line 19. And just snug it up there. Yes, because we're looking for an item in grades list. So grades list index I. We can come back to that. Let's take a look at bubble 7B, which you probably have to hit finish, and then 7B, which is this the air quality one? I think it is. Yeah. Okay, I'm just going to preload the other one. So this is a complicated app in what they give you. It's complicated in the way, or in the fact that we're using 8 different lists. And every single aspect of our filtering has 8 different lists, or there are 7 filtered lists. And we have one input is state dropdown. And you'll see this format frequently, where at the beginning of the program code, we declare filtered lists as empty lists. And then wherever we are doing the filtering, the first thing we have to do is wipe those lists so that the app can run multiple times without having to hit reset. Okay? Even though the first time through, they are already empty. The second time through, they won't be empty, so we need to wipe them. Okay, then with the dropdown, the event is the dropdown change. When the dropdown happens, the program gets the name of the state, calls it selected state, then goes through a loop. Again, it doesn't matter the name of the list for loops because it's just a number of times. State is getting, a new variable state is getting whatever state we're looking at, which is probably should be like that. You don't need to change it, but I think this does a better job of explaining, where we are checking every item in the list and checking to see if it's the same as a selected state, which you would think is only going to come up once. Okay, if you have a list of states and you're checking for a single state in that list of states, it will only show up once because there's only one state with each name. The thing is, it is critical to go and look at the table, the actual data. And if we look at this data, we can see it starts out with like 20 Alabamas, and then like probably the same number, maybe 15 Alaskas. Why is that? Well, we are getting data from multiple counties in each state. Okay, and the data itself or the columns we are going to use are the first one, days with average quality index or air quality index, excuse me. So days just means how many times that particular county took a measurement. And then all of the measurements fall into the category of good, moderate, unhealthy for sensitive, unhealthy, very unhealthy, and hazardous, and max, but I don't think we use max in this app. But the point is that there are multiple rows for each state, but it's a different number of rows for each state because the data comes from different counties and not just every state having a different number of counties. I don't think every county is accounted for, but it doesn't matter. So we're going to go through the list, and let's say we pick Alabama, because why not? And in the entire list of the state list, which is states' names, if the name in states' names is what we selected, we want to get whatever is in the same position of each of the different quality days and apply them to their specific filtered, or append them to their specific filtered list. Okay. This is kind of complicated. Hopefully, some of you will just get it instantly, and that's good too. But let's keep going. Okay, so the other input is the display stats, which doesn't work yet. Good. Okay, so the filtering happens, the actual going through the list, or wiping the filtered list and going through the list and seeing which rows have the state we chose and getting the numbers from each of the different lists and making a filtered list of just the data from that state. All of that filtering happens when the state dropdown is changed. Nothing changes on the screen until the user clicks display button. Display button has, well, it's designed to figure out what percent of each what percent of the total days measured fall into each one of the categories. So we have these outputs, or these variables, designed just to be the outputs, and we're going to go through a loop however many times any one of the filtered lists has items, because even though each state has a different number of counties, after we filter by state, each one of those filtered lists will have the same number as each other, because there's the same number of, well, just whatever. I don't need to repeat the whole thing. The filtered list will all be the same length. And we are going to go through, and total days is going to get total days is going to get whatever it used to have, plus whatever is in this filtered list, which, if we choose Alabama, will be a list of numbers, which are all of the numbers in the good day list on rows where there's Alabama. Okay, so then this will sum up each of those. And our goal is to take that sum from each one of the filtered lists, divide and find the average. I think this might be too much to just send you on your way. Find the average of each, or the percentage of total days that fall into that category. So what do we need? Well, we are going to, for each one of these, change them once we are done summing up or totaling up each type, we are going to assign each one of these, which we need to get rid of the var for each of these. I know that's tedious, but it's faster than typing each of these in and making sure they are spelling sensitive. And what are we going to give each of them? Well, we're going to give total. Oh, shoot. They aren't total days. What is our add code to calculate and display? Let's change these all to percent. PCT. No, it is total days. No, total days is part of our calculation. Okay. So we want, see, it's not total days. Total days is going to be our denominator when we calculate percent or decimal. So it's not, we don't need to wipe total days, which was the first one. But the other one, we want percent good days. We want percent moderate days. Just doing PCT for percent. We want percent unhealthy. And I think the point of this app probably could have been met by doing like 3 of these rows, or 3 of these characteristics. I think this is right. Okay, so our total days measured is the total day for each county, but once it's summed up, it will be the total number of days for each state, or whatever selected state. And the percent of good days is total good days divided by total days. And we can check this by, let's console log it. Let's console log everything we're doing here. Let's go total good days and total days and percent good days, just to see if percent works or good days work. So total days, total good days, total days. So everything we're using here, why does it say percent good days? Oh no, these all have to be var. My mistake. Change these because these are different ones. They are not declared yet. My mistake. Var percent good days gets, var percent moderate gets, and so on. These are all new variables. They need to be declared. Sorry. Console log doesn't need a var. And so this is what we're testing when we run. This is all going to be under the press the button. Okay, there we go. So for Alabama, there are 3,737 good days, and there were 4,454 total days. And so the percent of good days in Alabama across all the counties measured is 84%. Now, we are going to need to set the screen. Do we have an update screen? We're going to need to do a set property for these. Okay, so first, let's notice that we are looking for a percent and we are getting a decimal. Okay, those are different things. So how do we get a percentage based on a decimal? Multiply by 100. But we also don't want, well, let's just do this way. We don't want super long decimals, so we're also going to have to round it. So let's reassign percent good days to itself times 100. And we should get an output here of 83. After I select Alabama print. Okay, so we have 83, but we also want to round it. So we need to do math.round for that, which it's just easier to copy and paste it this way. Let's go like this and this. So math.round of percent good days times 100. Now we print that out, it should be 84. Oh, wait, again, we have to select state and display. There we go, 84%. And now we have a usable percentage of good days over total days. And then we can just set the property of good output, set its text property to percent good days. Now we should have this. There we go, 84%. All right, so very quickly do this for each of these. I'd say let's do it for 2 more of them. Okay. Do it for, if you've already done it, great. But I want this for at least moderate and unhealthy for sensitive groups. Okay. And I'll give you a couple minutes. I'll do it quietly on my own, and you can follow along if you want. Okay, so, well, I'll just go now that we've solved it. So percent moderate days is total moderate days divided by total days. These are all called total, and the other one is called filtered. Yeah, good. Okay, so we have, where did I just go? Okay, yeah. Okay, percent moderate days is this, but then we need to sort of massage the data into the format we want. So we're going to reassign it the rounding of itself times 100. And then a set property. Again, I mean, normally we would have all the set properties together, but I think it makes more sense to look at these as like separate entities where we're doing all of this just for the good days output, and all of this just for the moderate days output. And so we want to set moderate output, set its text property to whatever percent moderate days is. Percent moderate days. And let's see what happens if we do that. Good, there we go. We get another whole number. And the last one, percent unhealthy days, is total unhealthy days, or total unhealthy group days, and divided by total days. Then we need to change our new variable. We need to reassign it to the rounding. Not the, yeah, the rounding of itself times 100. And then we also need to set property of, I'm guessing it's called like unhealthy groups output unhealthy groups output, set its text property to % unhealthy groups. And I think some of the benefit for this is lost in the tedium, but there's a lot of good stuff here. Changing output to a usable output. Okay, instead of getting a decimal, we get a percentage and we've rounded it. Total versus filter total. I don't know if you're expected to get everything out of this, but we're going to keep moving. And all right, so the last one, this took a lot longer than I thought. This app goes through a list of prices of, you know what? Is next time, we might end it there because I think next time is going to be short and I don't want to rush this last one in the last 10 minutes. So we're going to leave the last bubble. I mean, feel free, but we're going to leave the last bubble until next time. And something to think about is the project coming up after next time, which we may even introduce next time. We'll see. Is going to be essentially one of these apps that uses the data set, but you get to choose the data set and how you use it. So it's probably worth your time to look through the different available lists, once you're done, and just be familiar with them in order to have a head start on the next thing. So let's see here. I'm going to end the recording because it's already crazy long. But